And I'm going to let Melanie as our moderator tonight, and I believe she might go over some rules, how she wants to run the room and keep it half organized.
What?
One problem with Zoom, as we all know, it's very easy to step on somebody in Zoom. So
Jerry, I think Melody's a little shocked.
Melanie, where there's Melanie and me, Melody, and I'm sorry, we've got TV in the background, but maybe you met Melanie. Is she with us tonight?
Nope, I'm here, but he didn't mean me. He meant you. I'm an innocent bystander.
Brittany, put Brittany on.
Yeah, I was actually trying to introduce Brittany. I was looking at Melody, and I guess I said Melody instead of Brittany, but I was looking at you.
You
I
should have
think the
saw
same
her
thing
face.
every time he calls your name.
Sorry about that. I just
That's
saw you.
all right. I'll get you back.
I saw you just came in. I was actually thinking if you had anything to say about the Institute, but you're retired, so no, you don't.
Not tonight.
Okay, Brittany, I'm sorry. That was the funniest thing I said all night, wasn't it? Okay. So.
Yeah,
Brittany, it's all yours.
You should have saw her face when you said her name. All right, so our experts tonight are going to be Jerry Jones. He's going to cover mining history and geology. We have Steve Lindbergh, who will cover geology. Todd Ullery, who is he's waving there, who's an astronomer. He is also a member of the York County Astronomical Society and Planetarium Director. And we have Paul Fagley, which we know very well from Greenwood Forest, as our experts tonight. So I guess how we'll do this is we can type our questions into the chat, or you could raise your hand. Just don't feel free to unmute yourself and ask questions because it's so easy to talk over each other that way. So we'll either type the questions into the chat or raise your hand and I'll call on you. Alrighty, so we can take it away with your questions. Don't everybody jump at once. Oh, Curtis is waving to me. So let me get him unmuted. You can go ahead and unmute Curtis. There's also the little raise hand icon somewhere. Honestly, I don't know where it is. Under reactions at the bottom, you can raise your hand that way as well.
Can you hear me now?
Yes.
Okay, so just ask any question.
Mm-hmm.
Okay, what's the difference between a gabbro and a norite? They're rocks.
I'm going to pass that over to Steve first. Is that?
Yep, I'm here. I might be slightly stumped on that one. I know a gabbro is the coarse-grained equivalent of basalt. They have exactly the same mineralogical composition. Basalt is the extrusive rock. Gabbro is the intrusive. There are lots of varieties. I know a norite is chemically different from a gabbro and a basalt. I believe it might be the content of silica or quartz, but I would have to check that.
Okay.
It's actually the difference is norite has hyperstein in it, a mineral called
Hyperstein. All right.
It's identical to gabbro except for the addition of hyperstein. Hyperstein, yeah, that was the mineral that always plagued me in optical mineralogy, and I think the saying was, when you look at hyperstein under a polarizing microscope, it turns pink and green. So the saying was, pink and green is hyperstein.
That's pretty good.
Alrighty. Alexa says she has a rock, but she's not sure what it is. So maybe we save that one till the end so we could talk about it a little bit, Alexis. Is that okay?
Yeah.
All right, sounds good. I won't forget about you. Michael says, and this was actually a Final Jeopardy this week or last week. 2 of the 3 men for whom armalcolite, a dark gray mineral discovered in 1969, is named. And I have to say, I saw that Jeopardy, so I know the answer.
Uh-oh.
The year is a big clue there.
I know the answer to that one.
All right.
Okay, Todd.
The year is the clue because it's named after the Apollo 11 astronauts.
Are you gonna name them?
Armstrong, Collins, and Aldrin.
Nice. All righty.
I see that it was a titanium-rich mineral. And yes, it was first found in Tranquility Base.
How can soft bodies be fossilized? For example, jellyfish.
I guess I'll start that one out. And if the conditions are just right and decay doesn't come in quickly, and the organism is covered up very quickly before decay gets to it, it can fossilize, and there's no guarantee that anything's going to ever fossilize. But if those conditions are right, particularly in soft animals, that needs to take place. Instant cover to prevent decay. And then if the pressures are right with the building of sediment and other organisms on top of it, it may turn into a fossil.
And a very fine grained sediment like chemical limestone or a very fine mudstone would greatly increase the chances for soft body preservation. So like Jerry said, rapid burial, a very fine grained sediment. Because we have fossils of octopus, and I believe octopus from the Solnhofen limestone in Bavaria. And there are jellyfish fossils, I believe, in the Maison Creek nodules from Illinois.
All righty. Thank you. Tom Smith has a question. He's unmuted.
Yes, it seems that people are misidentifying granite versus granodiorite. That much of what people talk about out west is really granodiorite. So I'm trying to figure it out in kitchen counters because I have these samples I want to give out to students here in another few weeks. And boy, is it tough. And I looked it up and studied it, but if you have some little tricks, it might help me and everyone else. Thank you.
You want to try that first, Steve?
Well, I think the problem with a lot of companies that are selling countertops is there are a lot of trade names, and the trade names are usually not reflective of what the actual petrology is of the sample.
I don't use trade names at all because I know that. I have whole books in this.
Yeah.
I taught the kitchen counter peoples that are pretty knowledgeable, and they don't know really. It's like black granite, which is really gabbro. There's no such thing as black granite, but
Right.
But-
There really is, yeah, there really is no such thing as black granite. It's gabbro or another dark, coarsely crystalline mafic rock. Um, I think to separate a granite from a granodiorite, I think number one, you need a good clear sample. You need a hand lens, and it depends on the I think it's the percentage of quartz. To be a granodiorite, the percentage of quartz is, I think it's more than 20%. So if it has more than 20% quartz, it's a granodiorite. And I believe it also has to have, usually granites contain both feldspars, the plagioclase feldspars, and the orthoclase, the K spars. So I think for a granodiorite, you need more than 20% quartz and a high percentage of plagioclase feldspars. I think it has to be up around 60% of the feldspars have to be of the plagioclase type.
And there's no really easy way to, the feldspars drive you nuts.
Yeah.
A good face of one of them with the trapezoidal type of thing, not trapezoidal, but parallelogram, rhombohedral shape, I guess. And I know, I find it difficult. But I'd like to know, and I keep studying it, but there's no quick seems way.
I really don't know if there's I don't know if there's a really quick visual hand identification, because you can typically have a fine-grained granite and a fine-grained granodiorite, and they'll look very similar, and it comes down to the percentage of quartz and plagioclase.
Mm-hmm.
And of course, the igneous rocks grade into each other.
Yeah.
There's no clear-cut boundary, and that's why we call it a granodiorite.
I know. Okay, thank you.
Alrighty, how can scientists find color from creatures whose DNA is badly degraded or just old?
Ooh, that's a good question.
Well, I'll just jump in here. I'm going to say for for example, for dinosaurs, we really have no idea. We have no idea what color T-Rex was, Stegosaurus, Triceratops. We really don't know. The dinosaurs that were feathered, we really don't know what the colors were. Probably the best preserved evidence of color that we have is from the nodosaur that was discovered in the Concretion in British Columbia several years back, that we talked about 2 weeks ago when I did fossils. I think some of the there was some coloration that was preserved in the plates on the back of that dinosaur, but that could have been altered. I really don't know of any accurate, and I could be wrong, but I really don't know of any accurate way that we know the color of fossil organisms like ammonites, trilobites. I think when you see those illustrations in books and movies, they're, we try to make them look appealing. And I think the color of fossil organisms might also be based partly on uniformitarianism. James Hutton's concept of uniformitarianism, what the things that we observe on the Earth today were probably true in the distant geological past. So if we look at living crabs, lobsters, horseshoe crabs, hermit crabs, and other arthropods in the ocean and crustaceans, we look at the colors that these creatures have, and we kind of say, well, there's no reason why the organisms that lived in the ocean 400 million years ago couldn't have had the same type of coloration. Reptiles today are extremely colorful. Look at the wide variety of lizards, iguanas, snakes. Reptiles are extremely colorful. Frogs and amphibians, turtles. So there's no reason to believe that there's no reason not to believe organisms that lived in like dinosaurs during the Mesozoic era, didn't have that same vibrant color. Because we know today that color in organisms is, it separates, males and females tend to have different color, and that's part of attracting a mate in the animal kingdom. So there's, we use the modern evidence to assume that these animals had a multitude of colors, but I'm going to just say that we're not absolutely sure exactly what those colors were.
Alrighty. That's really interesting. And there was actually something that came up in my news feed about a very rare skin preservation of a dinosaur that showed it that it was scaly, but I was just looking and it didn't say anything about coloring. What mineral is mined at the Climax mine in Colorado?
Oh, molybdenum.
Yep.
Yeah, molybdenum. I was in that mine and toured it years and years ago. Although I'm not sure if it's still, I'm not sure if it's still open. Jerry, are they still actively mining there?
It is still active, yes.
Oh, okay.
Yep.
All right. The interesting thing about that mine is, I think when I toured it years and years and years ago, I'd have to double check this, but I think originally when that mine was opened, it was owned by Germany, and molybdenum is used to strengthen steel. And the molybdenum that was being mined there was being shipped overseas, and the Germans were using it at the end of World War I and the prelude to World War II to strengthen the steel in their tanks. So I'd have to double check on that, but I think I remember that the person giving us the tour mentioned that. And I'm trying to think, the molybdenum is disseminated through the rock as little silver flakes and veinlets. And pure molybdenum is fairly soft. It almost looks like graphite. But when mixed with steel, I believe you get molybdenum steel, it becomes extremely hard. I'm trying to think what the host rock is for it there.
It's a porphyry
It's a porphyry.
of
I'd have to Google that. I can't remember the. I have it in my field book, but it's a quartz monzonite. I believe it's a monzonite.
It's now owned by Freeport McMoran Corporation,
All right.
which I'm not sure if that's a German company or not. World's leader in molybdenum.
I have a couple of samples of that somewhere. I know I have them stored away downstairs. It's an interesting looking ore.
That's a good question. I just had a friend come back from Colorado last week. He was touring all the sites in Colorado. So that's one reason I knew that answer.
Alrighty. Afghanistan has lithium. What are the minerals that lithium is found in?
Lithium minerals. What is a lithium mineral?
That's another good question.
It is a good question. And off the top of my head, I can't recall it. Lithium minerals.
Petalite?
Yeah, lepidolite. I was going to jump in and say lepidolite, and then I wasn't sure. I was doubting myself. The purple mica, or I say purple, but others say they describe the color differently.
Yeah, it's lepidolite.
Yep.
Kind of pink color.
It says on my phone here, it's a mixture of lithium chloride and potassium chloride.
You're muted, Cody. I don't know if they see you pointing.
Uh,
Sorry, I didn't want to be rude, but here's lepidolite. I just found it in Maine.
Yeah.
You would. Alrighty. Are there any living armored fish left?
No.
I don't think so. Yeah, I don't think so.
No. I don't think so. Yeah, I'll go with Jerry with that. If there are, boy, that would be something. I think the armored fish went extinct at the end of the Devonian.
Yep.
Yeah, placoderms, Arthur Dyer.
I have one for Todd. I saw the headline, but I wasn't able to have time to read the story. And it was supposed to describe why our planet and all the other planets and astronomical objects orbit on the same plane.
In star systems, when the sun and planets are forming, it forms from a very large cloud of gas and dust, incredibly large. And there may be multiple star systems forming from the same cloud. But as gravity pulls things in, there gets to be a preferred rotation direction. And that just happens naturally. Of course, the ice skate are pulling their arms in as they spin. They make them spin faster. But as this material gathers at the sun and the planets, they are all rotating the same direction as a group. And that's why all the planets go in the same direction. The other contrast to that is if you did have a planet going another direction than the rest, collisions would be more likely. And that would be bad for everyone around.
Thank you. Larry has a question. Go ahead, Larry.
I have a astronomical question. For years now, I've heard speculation about some planet in the outer solar system because of the motions of the outer planets. And in recent times, even heard speculation that there could even be a primordial black hole somewhere in the outer reaches of the solar system. I was just wondering what maybe the newest thoughts regarding that.
Well, the good news is it's probably not a black hole, because that would be really bad for us. We would detect it easily from things falling into it and giving off gamma rays and X-rays. It would stand out a great deal. So fortunately, not a black hole. There are theories about there being a planet 9 out well beyond Pluto. So far, we have not found any evidence of it. And it makes it very challenging to predict anything. There have been astronomers who, for the past decade, have been insisting this is where we should look for it, but none of their surveys have found a substantial size planet. There are thousands of minor planets out beyond Neptune.
All righty, thank you. How would dinosaur vomit be preserved while still in the body of a dino?
What was that?
How would dinosaur vomit be preserved while still in the body of the dino?
I'm not sure if there's ever been any preserved internal organs of dinosaurs found, or fluids.
Yeah, I'm not aware of anything.
I
No.
know, yeah, I know of eggs and coprolites, but not.
Yeah, I think there is I think it was a hadrosaur that was found that was mummified before it was fossilized, and I guess X-rays or whatever they use to penetrate it does show the organ structure in it.
All right.
But I don't know that it would show like vomit or anything like that. Yeah. And they just found another one recently, I think up in Canada, another like mummified type of fossilized dinosaur. And I remember there was a show on one of the channels about this hadrosaur. And they talked about that they actually could make out the internal organ structure.
Mhm.
Very cool. Might need a little more clarification from Dick on this. How did Mason Creek fossils form in small rocks, in the small rocks?
At the fossil site in Illinois. That's about 307 million years old, where they find fossils mostly in iron, iron nodules. So the iron apparently is accumulating on the ocean floor, shallow ocean, and the animals are falling into the iron-rich sediment, and then being formed, then actually forming into a ironstone, as they call it out there at that site. But they're pretty small fossils in this. They're like nodules, I guess you can say it. From what I know about it.
Alrighty. What is cosmic dust made of?
Cosmic dust is everywhere. It is from just a few atoms put together to maybe a millimeter across. It can be formed from volcanic eruptions, comets coming through. There's a lot of dust out there in space that will in the future pull together and make solar systems. But it can be ice, it can be silicone, it can be carbon based. It's all out there. I should say, in astronomy, anything heavier than hydrogen and helium is considered a metal.
Why are grapholites a good index fossil?
All right, grapholites were mostly a lot in Ordovician aged rocks, and grapholites either were attached to the ocean bottom, or there were some free floating grapholites. They lived in colonies, very similar to a coral, except they look like I call them a double-edged saw blade. Is what they look like. They're not microscopic, but they're small. And there were a number of species, but those species only lived a fairly short time in geologic time. I'm saying, again, I'm just throwing this number out, several millions of years, several hundred or several thousand millions of years. So if you find a specific grapholite in a rock, that actually is related to a certain part of a geologic time, particularly in the Ordovician period. And so there's been some very good dating of the one I'm acquainted with is up in the Lebanon Valley between Harrisburg and Allentown. There've been grapholites found in that area that the geologists could actually give them a very exact date of the age of that rock because of which species of grapholite was found there. Anybody else want to add anything to that? Help yourself.
All righty, Melanie did some research for us, and Larry was correct that there are 2 species of armored fish left. Okay, next question is who found the first dinosaur eggs?
Oh, boy.
I actually Googled that.
Well, you're not being stumped if you're Googling.
Well, I stumped that. I had to Google it. I was stumped.
A fairly famous paleontologist associated with the American Museum of Natural History, Roy Chapman, went on an expedition to the Gobi Desert several times. And in 1932, he returned to the American Museum of Natural History with a large assortment of dinosaur eggs. But they had also discovered a lot of fossilized dinosaurs. But when he made the discovery in Gobi Desert, it caused quite an international excitement. And when he returned to the museum, everyone ignored the other discoveries he made about dinosaurs and just wanted to talk about the eggs that he had discovered. That was the first really well-publicized one. And I believe those dinosaur eggs are still in the collection of the American Museum of Natural History. I believe they were Protoceratops eggs, but the first recorded, well-documented example of dinosaur eggs was a French Catholic priest who was exploring the Cretaceous period rocks in the Pyrenees Mountains, and I believe he discovered dinosaur eggs or dinosaur egg fragments in the mid 1800s, maybe the late 1850s or early 1860s. And offhand, I cannot remember the Frenchman's name, but he was a Catholic priest and a naturalist. So that's a well-documented description of dinosaur egg fragments from the mid 1800s.
And his last name was Pouech.
Oh, okay. Well, I don't know how to pronounce that. My French is
Yeah, that's why I spelled it.
Poche.
Yeah. 1859. So you were right on.
Oh, 1859.
Yep.
I'm not that. Yeah, I don't know if that's the discovery date or the publication date, or but it was much earlier than Chapman bringing stuff back from the Gobi Desert. And of course, Gobi Desert is that's like dinosaur egg mecca out there. There's some layers and units out there that are just packed with fossilized dinosaur eggs.
We'll just skip right to that question then of why is the Gobi Desert so good at preserving those fossils?
Well, let's see. I'm going to say that at the time those eggs were deposited, dinosaurs migrated in huge herds across the continents, and that region was favorable for springtime nesting, and probably the humidity, the climate. So when herds of dinosaurs reached that point, they nested in huge areas, huge brooderies, and we believe the eggs were covered by massive dust storms or collapsing sand dunes. A lot of the dinosaur eggs that are found there, though, are hatched. If you, I know right now it's very difficult to acquire a dinosaur egg as a fossil because they're highly, I don't want to say regulated, but countries protect those as a national treasure. It's not as easy to get actual dinosaur eggs as it was 30, 40, 50 years ago. But anyway, most of the eggs that were sold on the market, when you look at the fossilized dinosaur egg, you've got a beautiful round top, but that's actually the bottom of the egg. The people that were chipping them out of the sandstone layers, they'll find the dinosaur egg nest and they'll undercut it because most of the eggs are hatched. And then what they'll do is they'll remove the egg and turn it over, and they'll excavate, they'll remove the matrix, the surrounding matrix from the bottom of the egg. So you'll see these nice round or oval dinosaur eggs sitting on a piece of matrix. In reality, you're looking at the bottom of the egg. If you were to cut away the other side and turn it over, you'd see the top of the egg would be shattered. But there have been dinosaur eggs found that still have the embryonic dinosaurs in them. So the short answer is it was a nesting area that was for the migrating herds of dinosaurs.
Thank you. Did Raptor Rex ever exist?
That's supposedly a genus of the T-Rex. And the only information that they got about that is from one juvenile skull that was found over in Europe, I believe it was. I know the word dubulous is used with that, like questionable if it was a separate genus compared to T-Rex or not. So again, all that information came from one single juvenile skull.
Alrighty. What was the biggest frog that ever lived? I already Googled it, so I could take
I
it.
just saw that somewhere. I saw an article on that somewhere. I know, but I didn't take the time to read it. I just looked at the picture and the caption, but I saw an article about this huge frog. I'll pass that off to Jerry. But I know there was an enormous frog, but I can't remember the geologic age and where the fossil was found.
I think his name is Kermit.
I'm going to have to Google that, but that is a pretty cool fossil find.
I do not have an answer for that.
I did Google it when I saw the question because I have to know this one.
Yes, I'm Googling it right now.
Beelzebufo, so-called devil frog, maybe the largest that ever lived. These beach ball sized amphibians, now extinct, grew to 16 inches in length and weighed about 10 pounds. They inhabited the island of Madagascar during the late Cretaceous, about 65 to 70 million years ago.
We're looking at the same website, Brittany.
Great minds think alike.
That's a big frog.
Yeah, I recommend Googling that.
Yeah, you don't want to catch those frogs and get into a fight trying to separate them from their legs for dinner. So you might end up as dinner.
When in geologic history were plants located in the Arctic?
Oh. I'm going to go out on a limb and say that there are rock layers in the Arctic that date to the Carboniferous period. So Carboniferous period would put us where about 330, 340 million years ago in the Mississippi and Pennsylvanian. So if they're in the Carboniferous rocks, that would be the upper middle Paleozoic era. There are also, not being that familiar with Antarctic geology, if there are Silurian and Ordovician, which I imagine there are in the Antarctic, there would also be some primitive plants in there also.
Alrighty.
You can fact check me on that.
Everybody quick, fact check Steve.
Fact check me, yeah, fact check me. I'm not sure. I'm Googling it right now.
Every time we say the word Google, that means you've been stumped, by the way.
Yeah, that's fine.
What are the polymorphs of quartz?
Simply an alpha quartz and a beta quartz. A low quartz and a high quartz. So there's right-handed quartz and there's left-handed quartz, basically.
Alrighty. There are many ancient faults in the eastern US. Given that tectonic forces are still at work, have there been any evidence that these faults are still active?
Well, certainly so. Wherever you have an earthquake on the East Coast, 95% of those are occurring in a fault zone, just like the one that we had in Mineral, Virginia, back in
Right.
what, 15 years ago or so. Maybe not, maybe 8 years ago. So yeah, there's one. I still call it the border fault that runs from southern New York through Pennsylvania down into Maryland. It's the border between the Mesozoic rocks and the older rocks, called the Ramapo Fault, which has relieved itself a few times. More in the in Pennsylvania, more in the Reading, Sinking Springs area. Of course, over in New Jersey, they've had some earthquakes too. So yeah, there's still evidence that these faults are some of these faults are built up pressure. Go back to my legacy with the Dillsburg earthquakes of 2008. We are not convinced that there's faults there to making those earthquakes happen. That and maybe something that caused those to happen more than a fault. It may have been the amount of weight on the crust and pushing it down, hydrostatic relief. So, okay.
Alrighty. How did the pygmy mammoth come to exist?
You got me. I'm stumped. That's what a subspecies of
It's a dwarf.
yeah, dwarf. So the I can answer that in one word: evolution.
You never go.
Oh, and by the way, yeah, just to go back here, I'm still looking up Antarctica. So Glossopteris leaves, which totally slipped my mind. Glossopteris leaves, which were one of the big fossil plant indicators of Pangea. Glossopteris leaves are present in a lot of the rock units of Antarctica, and that's Permian to throughout the Permian period and uppermost Pennsylvania. As a matter of fact, Robert Scott of Antarctic fame, who died at the South Pole, recovered Glossopteris fossils in their expeditions there.
Alrighty. What is the Salisbury embayment?
I can try to answer that one. Our East Coast coastline is not a straight line, and it never has been. So even when we were living on the previous continent called Laurentia, before we became part of Pangea, we were known as Laurentia. Laurentia itself was, again, the coastline on the East Coast was not just a straight up and down line. It was in and out bays, okay, and just like we have today, the Chesapeake Bay, the Delaware Bay, making our coastline irregular. So the Salisbury embayment, named after Salisbury, Maryland, was one of these, I'd say, where the coastline came in onto Laurentia more than just a regular coastline. If that makes any sense. Yeah.
Alrighty. It is now 8 o'clock. So if you have any last questions, get them in, and we're going to try to finish up with the questions that we have. How can scientists find direct evidence of single-celled organisms?
I think take us back into Precambrian days when most of the fossils, all the fossils that were being found in the Precambrian or Proterozoic now are single-celled animals like algae.
Wasn't there this one creature that they didn't know what it was, but it was before the Cambrian explosion, and it was one of Earth's earliest animals. It was like a big blob.
Okay.
They didn't know what it was or even if it was a creature.
Was that
They figured that out by one guy who thought outside the box, and he crushed up some of the fossils, like went and found some and then crushed some up. And then he measured the things of the amount of chemicals or whatever it was inside the rock and found that it led more to an animal that was more likely to be an animal rather than a weird movable plant or a massive amoeba thing.
Okay. Yeah, there were a number of single-celled animals back in the Proterozoic days. You know where that find was from? Was that from Greenland or?
I don't know. It's been a while since I watched the video, but I think it was a mountain range or something like that.
Okay. Certainly, some of the oldest rocks that we have in the world came from Greenland, even Michigan, northern, Canada area, Australia. So there were, as I said, there were a lot of single-celled animals present in the fossil record before we started to know of our marine creatures.
Yeah, we certainly have, we have well-preserved and semi-well-preserved stromatolitic fossils that go back into the Precambrian, at least 3 billion years. Australia and in the several regions in Australia preserved in the siliceous charts. There's microfossils of single-celled organisms, but I guess the stromatolites would be the most abundant and easy to detect.
And still living
And
too.
Right, and still living, yeah,
Still living.
and still here.
Nice. Avara Bago put a link to the video into the chat. Don't worry, I won't forget about Alexis's rock. And we got a couple more questions and then we'll get to that. Hales Gap, Kentucky is known for a nickel sulfide mineral. What is it?
Millerite. Nickel
Nice.
mineral. Hall's Gap produces some great geodes of the hair, usually hair like millerite. Pretty incredible geodes if you ever saw any of the Hall's Gap stuff.
Righty. What was the first supercontinent and how many have there been?
I can't keep track without looking now anymore. The one I still teach about is the billion-year-old Rodinia.
Rodinia.
But if you look on the internet, and I'm not cheating here, I believe now before Rodinia, now we know of about 6 supercontinents dating back to 3.8 billion years ago. Yeah, and I can't really give you that list without looking because I don't use it too much in what I do, because the oldest stuff we have in eastern Pennsylvania here is Rodinia. So why should I worry about anything else older than that, in a way? But yeah, if you look on the internet, it's going to give you like 6 other names now previous to Rodinia.
And I agree with Jerry. I usually don't go back further than Rodinia because we probably have the best evidence for Rodinia, the rock assemblies for Rodinia. And you go back further than that, and it becomes more and more difficult to reconstruct. I mean, the further you go back, the less evidence we have. So I tend to stop at Rodinia.
Righty, how deep is the bedrock in South Jersey?
Mm.
Well, that's more like a trivia contest question. It's South Jersey.
Talk about Cape May, Wildwood,
12 miles.
Oh, so like around Cape May County and that, how deep down would you have to drill to get to bedrock? Underneath the coastal plain sediments? I'm just going to take a wild guess and say 8,000 feet. And then I'll Google that to see if I'm correct.
I'm gonna say 300 to 600. All righty, let's just do a couple more. From Andrew, once sulfur has been removed from pyrite by oxygen and water exposure, what color is the pyrite afterwards?
I think someone was stepping on when you were reading the question. I couldn't hear that.
Once sulfur has been removed from pyrite by oxygen and water exposure, what color is the pyrite afterwards?
That's called a limonite pseudomorph, where the sulfur's been replaced by oxygen. Formula now is FeO, which is the mineral limonite, better known to many people as rust. And if you find a pyrite crystal that used to be its yellowish color, it is now rusted to a brownish color. And if you kept the crystal shape of the cubic shape of pyrite, around here we call them limonite pseudomorphs, meaning false form. The chemistry is limonite, but the crystal form is pyrite.
All righty, Greg, you want to go ahead?
What'd she say? Are you referring to me?
Yes.
Whenever you go to caverns and caves, the leader will tell you that stalagmites take anywhere from, depending on who you're talking to, 10,000 to 100,000 years to grow an inch. However, I've been under bridges and in tunnels and overpasses and things like that, where I've seen stalactites at least 6 to 8 inches long, and none of those structures are more than 100 years. So what's going on? It can't be 10,000 years if you got a 6-inch stalactite in 100 years or less.
Right. In the cave situation, it's all dependent on the climate. I've heard different things for different areas. And, like you said, depends on where you're visiting. Around here, we use takes 100 years for 1 cubic inch to form of a cave formation. Now with your bridges, again, just my guess would be that the bridges have calcium carbonate in from the concrete, so the water instantly the rainwater is instantly going down through the concrete, dissolving the concrete, because we have acid rain, and you know what acid does to calcium carbonate. It eats it away and carries it away. So those formation stalactites on the bridges are being formed quicker than the region's average for a cave formation. If that makes sense. If that makes sense to you.
Yes. And there's also a difference between natural limestone and man-made concrete, and they'll weather at different rates. So
Wouldn't the formation process be the same time rate?
I think it'd be quicker with man-made because there's more calcium carbonate involved in the bridge, and compared to like this, the limestone has other elements within it. That's not purely calcium carbonate necessarily.
and it may also be a function of temperature, because when you have concrete overpasses exposed outside, you're getting a wide variation in temperature during the different seasons, and that's going to change the weathering rate. But in a cave, the temperature is fairly constant year round. You don't get that much of a change.
Thank you.
Oh. All righty. Gonna be 8:12 right now. I think you guys have asked some pretty amazing questions, but I think I want to get to Alexis's rock so we can, since we have so many of us here still, maybe we'll be able to help her out and figure out what it is based on what she has to tell us about it.
So real quick though, coastal plain, the answer to the coastal plain sediments, I did Google it. At the fall line, the thickness of coastal plain sediments is 0, and it thickens to about 12,000 feet. So as you leave the fall line and go out across the East Coast, and then you go down on the continental shelf, there are places where it varies greatly, but you're going from 0 down through a wedge of sediment. For instance, in Virginia, a mile off the coast, the coastal plain sediments are about 12,500 feet in thickness before you hit bedrock. So.
Awesome. Thanks, Steve. All right, Alexis. Tell us what you got.
Okay, so I was actually rock hounding one day, and it's just kind of like got this like weird little shape to it. And I've asked a couple people, but they've never really knew what it was.
Let's see. I'm going to, there we go.
There we go. That's good. Did you try to put acid on that? Or
No.
baking soda? Okay.
Do you have any vinegar there in the house with you?
Yes, I do.
Yeah, if you can grab some vinegar real quick, grab some vinegar and pour some on the rock. And if it's a carbonate, it will fizz.
Do that really fast.
What do you think, Jerry? If that's a limestone, it looks like a little bit of karst.
Yeah, karst fracturing going on there. That's why.
Where did you find it?
She probably can't. She may not be able to hear you now.
Let me just grab the vinegar really fast. Does it matter what kind of vinegar it is?
Nope. Nope.
Okay, so this could work.
Yep, that should work.
Okay.
We're getting a hands-on demonstration here.
Yeah, this is great.
Oh, no fizz. Okay.
No fizz.
So, like Curtis said, it could be a silicate, like quartz.
Kind of making like a little bit of a bubbly noise.
Wondering if that fracturing is actually maybe some calcite veins or something.
It's making little bubbles at the bottom.
Yeah, I can see that.
Or
Where
little-
did you find it? Did you say where you found it?
I found it in a cave, actually. Tituna Cave was the cave I found it in.
No, I don't think it's not bone. I don't know. It doesn't look like bone.
No.
So where's the cave?
Tituna Cave's up around about a couple 30 minutes from Saxton. It's
Oh,
kind
in
of like
Be-
hidden back a good bit.
That's Bedford County.
Yeah, I believe it's somewhere around in that area.
Yeah, this
Well-
is a good one.
Yeah, yeah. I mean, it looks like it looks like a product of weathering. I mean, if it's from Bedford County, it's not metamorphic and it's not igneous. It could be. It doesn't look like quartz.
Could it
when
be
you're
a
done, though.
severely weathered calcite?
Yeah, it might be slightly dolomitic. If it's slightly dolomitic, with it will not bubble that much if it's a dolomitic limestone. Yeah, IDing stuff on video like this can always sometimes be tricky. But here's the best thing you can do when we're done with tonight's program: rinse it off real well, put it in a small box and mail it to Jerry, and you'll get your ID within 2 minutes of the time he opens the box. So that's the best thing you can do.
Are you coming to the October 24th field trip?
Yes, there'd be two.
You can
Bring that with you.
Bring it with you.
It with you.
Okay.
Yep.
Oh yeah, bring it on October 24th. Yeah, and then we can all take a look at it firsthand.
Okay.
That's awesome.
A lot of times things are easier to identify if they're in our hands.
Yeah.
Definitely.
But like the chat says, you win the prize tonight for Stomp the Experts. We don't have a prize for that, so
It's a neat looking rock.
yeah. Okay, that's good.
Now I gotta figure out how to remove. There we go. We should all go back to galley, did we? There we go. Alrighty. Well, thanks for sharing that. We will have to let the rock group know how that pans out afterwards. So, alrighty. You want to say anything, Jerry?
I just want to say I'm totally impressed with the success of this impromptu program, unrehearsed. And boy, you folks brought it on tonight. Yeah, we used the word Google more in the program tonight than we did giving actual answers. So I believe you all did stump the panel, and I will thank Todd Eulery. He had to leave for another Zoom meeting, but I do thank Todd. He's a longtime friend of mine in astronomy, for being here. But you guys brought it on tonight, and that was great. And being recorded, so if you wanna brag about your stumping the panel, it's going to be online that you can tell your friends about. So
Yes, amazing questions. And how about our experts, though? I mean, not too bad, right? Amazing.
Yeah, good questions. And I was stumped, and I wrote everything down. So I have to go back now and study all those questions I missed. And hopefully my petrology professor will never find out that I forgot what a norite was.
yeah, we don't see them. We don't see those in Pennsylvania at all. So
no.
I'll forgive you for that one.
So my
Well, and
final,
just,
go ahead, Steve.
I was going to say, and just as a footnote, October 24th, our day at the New Paris Limestone Quarry, and it's just that it's just